Hi class, the purpose of this video is to talk about the geologic cycle, and this is best described as a series of cycles. So I'm going to put that here. I'm going to put this for it is best described as a series, if you will, of cycles. All right, and the four that are most important here, we're going to talk about one really in this particular, but the first we're going to talk about there is the tectonic cycle. Several of you told me in class you're somewhat familiar or are familiar with the theory of tectonic plates. We're going to talk about that a little bit. The second is the hydrologic. All right, which we're going to be working on the assignment we're going to be working on the water cycle basically. The third is the rock cycle. All right, and the fourth is I'll just say, and the biogeochemical cycles. All right, and some of these that we're studying right now are going to be things like the nitrogen cycle, the carbon cycle. We are also talking about the phosphorus cycle for 3. Okay, those are 3 big ones right there, so I'll just leave those 3 for now. So we'll need to be familiar with those. Biogeochemical basically means that there are bio would be living. All right, so some living organisms contribute to this cycle. And the geo would be the earth. All right, so these are basically, in effect, the biotic components and something called the abiotic of the biogeochemical cycle. We'll be talking about these in class. Right now what I want to do is talk a little bit about something called the tectonic cycle, or the theory of plate tectonics. I'm going to put both terms here because they are important that we understand both of these. Theory of plate tectonics. All right, and just a few things about this I think are the most important. This involves basically the creation and destruction of the Earth's solid outer layer, which is called the lithosphere. So this involves creation and destruction of the Earth's outer layer, which is called the lithosphere. We talked about that in the last video. All right, and just another characteristic, this lithosphere, all right, is approximately 60 miles thick. All right, and is broken into several large fragments called plates. It's broken. Several large, if you will, fragments. Called plates. All right, And the slow movement of these plates is called plate tectonics. Plate tectonics. The slow movement of these plates. All right, and this is called plate tectonics. The plates, the characteristics, I'm just kind of lining up some key, what I think are the most important characteristics about plate tectonics. Number 4, the plates float on denser material. Float on denser material, if you will. All right, their movement is slow, is at a rate of about 2 to 15 centimeters per year. So that's the estimated rate of movement of these plates. All right, and just a little bit of background on this. Initially, the thought was when the Earth was formed, that there was a hypothesis developed by Alfred Wegener. So I'll just call this is about 1912. Alfred Wegener. All right. He published a hypothesis which is basically called Pangaea, and that is spelled P-A-N-G-A-E-A. This is kind of a precursor, if you will, to plate tectonics. All right, and the idea was that with Pangaea, all continents were basically all joined together, in effect. All right, had been joined. In a single landmass. All right, and after this came along the theory of plate contact. The Pangaea was accepted for quite some time before some additional scientists came and started developing the idea of plate tectonics. So let's talk about that a little bit, and we'll talk about the different types of plates. So basically, we'll call this 6. And I'll say the types of plate contact. You can almost imagine these plates like I'm just going to put here like pieces of a jigsaw puzzle. All right, in terms of getting the idea of what these plates are. So the types of plate contact, the first one would be called divergent plates. Divergent, we'll call these divergent plate boundaries. All right, divergent plates move away from each other. Plates move away from each other. Apart. All right. And then I'll put a little I here. When this occurs, magma from below can reach the Earth's surface and pushes up, which forms new rock. So magma. You've got a little crevice, if you can imagine a little crevice as these two plates are splitting, all right? Then you can see the magma could go in the crevice. This is molten magma, comes up, basically is subjected to a lot of very cool temperatures and solidifies. And it creates new lithosphere. So let's see, so magma from below. All right, reaches the Earth's surface. All right, pushes upward. And creates new rock, forming new rock. All right, and this process is called seafloor spreading. Seafloor. All right, and basically new lithosphere is created. All right, so new lithosphere is created. By the way, there are, just as a, I'll put this as three eyes here, there are oceanic plates. All right, oceanic plates, you can imagine, are under the oceans. All right, and I'll put this as IV. Continental plates. Plates lie between land masses. All right, so continental and oceanic plates. All right. The second type of plate contact is called a convergent plate boundary. So I'll put this as B. Convergent plates. Convergent plate boundaries. All right. And these are plates that move toward each other and collide. All right, and something can occur here called subduction. That is a key term to remember. Subduction is basically when one plate slides under the other. One plate slides under the other one. All right, and this would typically be the lighter, if you will, plate is on top typically. The heavier plate would be on the bottom. This is sometimes, by the way, called the area where subduction takes place is called a subduction zone. All right, a subduction zone, that's a key term to remember as well. And typically let's go up here, two eyes for this one. All right, a subduction zone basically helps form mountain ranges, or can form mountain ranges. Subduction forms mountain ranges. An example of this I'm going to put here would basically be the Andes Mountains, e.g., for example, Andes Mountains in South America. All right. The third type, I'll put this letter C, the third type of plate contact is called a transform fault boundary. All right, and this is when two plates slide next to each other. All right, this is a good example of this would be the San Andreas Fault in California. All right, so types of plate boundaries. Now what I'd like to talk about is faults and earthquakes for a few moments. All right, so faults and earthquake. All right, so let's just define what a fault is. A fault is basically a fracture. All right, let's kind of define this here. I'll put this as a fault. Sometimes the movement for plates is not smooth. All right, so we'll just say a fault. All right. A fracture. All right, a fracture in rock across which there is movement. All right, so a fault here with this. And basically, earthquakes occur all right, and earthquakes an important consideration. Earthquakes occur when the rocks of the lithosphere rupture unexpectedly along a fault. All right, when the rocks of the lithosphere basically rupture, all right, unexpectedly, if you will, along a fault. And then C here, I'm going to say letter C, volcanoes occur. All right, occur when a plate moves over a hot spot. A plate